The amplitude or height of a sine or cosine wave is the coefficient of the function. The sine function shown has an implied a value of 1, so the amplitude of this wave is 1. The amplitude or height of a sine or cosine wave is the coefficient of the function. The other sine function shown has an a value of 2, so the amplitude of this wave is 2. The distance between a trough and a crest is equal to twice the amplitude. Notice in the second example that the distance from the crest to the trough is 4, or twice the amplitude of 2. Let's look at an example of another sine wave. The function y equals 3 sine x produces a wave with an amplitude of 3. Notice how the crest of this sine wave is located 3 units above the x-axis, and the trough is located 3 units below the x-axis. Let's compare that with the sine wave produced by the function y equals negative 3 sine x. Notice how a negative amplitude shifts the crests and the troughs. If the coefficient of the sine function is a small number, the amplitude is reduced, producing a much flatter wave. The cosine function behaves in the same manner as a sine wave. It is just shifted to the left with the crest at the y-axis. When b, the coefficient of x, is equal to 1, as in this example, the sine curve will repeat itself every 2 pi units. This is just over 6 units. If b, the coefficient of x, is 2, the period is only half as long as shown here. Cosine waves behave in the same manner as sine waves, except the wave begins at a crest. Here is a cosine curve with a period of 2. Notice that one complete wave from crest to crest occurs in the interval from x equals 0 to x equals 2. Cutting the coefficient of x in half cuts the frequency in half. There is now only half a wave in the interval between 0 and 2. The period is now twice as long, so the wave begins to repeat again at x equal to 4. The phase shift tells us where a wave begins. For a sine wave, we consider the starting point to be a point midway between a trough and a crest. This example shows that a sine wave with no phase shift starts at the origin. When c is positive, the shift is to the left, or in a negative direction. In the example shown here, the shift is equal to -1. A negative c value shifts the curve to the right, or in a positive direction. In this example, the phase shift is equal to 1, and the starting point of the sine wave is shifted 1 unit to the right. With the cosine function, we consider the crest as the starting point of the wave. Here, the phase shift is 0, and the curve starts on the crest at x equals 0. Once again, a positive c value causes the wave to shift to the left, or in a negative direction. Here, the crest is shifted 1 unit to the left, to x equals -1. The wave shifts to the right, or in a positive direction when c is negative. Here the crest shifts 1 unit to the right.